So how do we find the binding energy of a nucleus? Recall Einstein's famous equation, E is equal to mc squared. A proton mass, or the energy mass equivalent, like we have spoken before, is 938.3 MeV, mega electron volts. A neutron's mass energy equivalent is this much, 939.5 MeV. So what we need to do to figure out the binding energy of a nucleus is add up these for all the nucleons present. That's Z, that's the number of protons, times the mass equivalent for a proton. And then N, the number of neutrons, times the mass equivalent for neutrons. And then we take from that, subtract from that, the mass of the nucleus, the overall mass of the nucleus. That would be, the difference would be the binding energy. Delta M is the binding energy. So we find the mass of all individual protons plus the mass of all individual neutrons and subtract it from the overall mass of the nucleus. That's the binding energy. Let's look at an example. For example, deuteron. The overall mass is given as 1875.6 MeV. In the case of the deuteron, that's one proton plus one neutron. So we add these up. We subtract from, this is here. And then we solve for the binding energy. That should come out as 2.2 MeV.